Bismillahirrahmanirrahim. For the beginning, this report is represents by analysis of data collected, organized in Excel spreadsheet. The Excel is widely used in tools to data analysis and uh, the due its versatility and the easy to express. The function that built in Excel is, however, easily and easily to understand and easily to represent to the public. Um, our data collection, our sorting, and our statistic could be taken from the Excel easily using the built-in function. It is important to master the Excel with the power in mathematics and science to have a good Excel skills. Now, the problem that we solve with using the skills using the Excel to present it with accurately and smoothly. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is AHMAD Hazmi Najib bin BADRI Najib. My metric number is 2113381, and I will talk about analysis. So the first thing we need to do is to analyze the question and find all the information that was given to us. So the question is: a simple hydroelectric system with 60 meter cubic of water is elevated 15 meter above the turbine, and the flow rate was identified as 5 meter cubic per second. Due to power loss, the efficiency of the system is estimated to be 75%. Take density of water as 998 kilogram per meter cubic. So from the question, we can get we can put the information in the table. So the first information given is the volume of water, which is 60 meter cubic. And the next is height of the water from the turbine. Height of the surface of the water from the turbine is 15 meters. So height is also known as total height. So next is flow rate. Flow rate is 5 meter cubic per second. Next given information is density of the water is 998 kilogram per meter cubic. The efficiency of the turbine is 75%. And even though it was not given in the question, but we know that gravitational acceleration is equal to 9.81 meter per second square. So after we gather all the informations, we need to analyze the questions and identify formulas that we will use to solve the question. So for the first problem, uh, it wants us to calculate available energy for the elevated water. So we know if something was elevated, it has potential energy. So for that, we can use the formula potential energy is equal to mgh, which is mass times gravitational acceleration times height. Okay, so we will get the total potential energy of the whole water. But we can also find energy per unit time. Therefore, we can use the formula of natural flow of energy, which is equal to rho times G times Q times H. Rho is density of water, G gravitational acceleration, Q is flow rate, and H is height. So for the second question, it wants us to estimate available height if it has good piping system. So we will use formula HA equal to HT minus HF, um, which is HA is available head equals to HT total heat minus HF if there's friction loss in the pipe. So friction loss in the pipe is approximately less than uh, total total heat over 3. So for the third question, it want to we they want it want us to find hydropower delivered by the hydroelectric system. So, for the first question, we find the natural flow of energy. But since there are some power loss in the for the turbine, there will be some power loss. Therefore, we need to multiply it with the efficiency. Therefore, the power output is equal to density times gravitational acceleration times flow rate times height times efficiency, which is 75 per 100. So moving on to the next question, question 4. It wants us to find available heat for over 5 years period if the water level is um, if the height is decreased 1 meter per year. So the formula that we will use is exactly the same as what we will use in the question 2, which is HA equal to HT minus HF, and HF is approximately lower than HT over 3. But for this question, we need to find the available heat for each year over for the 5 years period. Therefore, we can get the data, and um, we can plot the data that we have that we got. Okay, so the final question, it wants us to give a meth. It want to know how to maximize the power output. So if we inspect the power output equation formulas, density times gravitational acceleration times Q times H times efficiency per 100, um, we can see that if we increase one of the variables, the power output will also be increased. So in this case, we decide to increase the value of height, which is equals to total height. So therefore, if we increase the height, the power output will also be increased. And we can, with the increased height, we can find the available height using the formula in the question 2 and question 4. So that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is AIMAN HAKEEMI bin JAMIL. My metric number is 2111143. So I will talking about the results for the lab report for part B. So first of all, we need to collect all the information that been given from the question, which include all of the information: volume of water, height, flow rate, density of water, efficiency, and gravitational acceleration. So this is the value that I have been collect in one table. So for question number one, the question want to calculate the available energy. So we can find it for the total available energy of water, which total mass of water times gravitational acceleration times height. Or we can find the natural flow of energy also by the formula gravitational acceleration times density of water times flow rate and times height. So these are the answer for the values for each parameters that we want to find. So for question number 2, estimate the available head for the system with a good choice of 5P system. So this is the estimate for the available head. So we just take the minimum available head as 10 meter. So for the next question, question number 3, estimate the hydropower flow of energy. So from the question, we can find the flow of energy by using the value for natural flow of energy 734 to 78.5 and estimated flow of energy, which we just are using the efficiency. which is 75% times the natural flow of energy, and we will get the answer. So for the next question, plot the available head for the system in 5 years. 5 years. So for the next 5 years, if the water reservoir level decline by 1 meter per year, so we need to plot the available head for the system in 5 years. So for the calculation, we just need the for using the formula height minus the year minus 15 minus year over 3. So for this is for the next year. For the next 5 years, which is 0 is this year, and for the next 5 years, and this is the minimum available head needed. And for the next slide is the graph for the plot available head for the system in 5 years. Okay, so for the last question, question number 5, which is the explore the option to maximize power output for the system. So by maximizing power output for the system, we just need to be increasing the head, which is the total height, total head. So by increasing the head by 5 meter per year, 5 meter. So this is the minimum available head, and the power output we can find by time efficiency times flow rate times height times gravitational acceleration and times efficiency over 100, and we will get the answer based on the height increases. So that's all from me. Thank you. And for the next slide is the graph for the power output vs minimum available head. That's all from me.
I will continue for the discussion. So after the discussion, we found out that we need a sufficient available energy in the water volume. So it will flow the water to the turbine without any problem. And the water will spin the turbine and convert kinetic energy to the electrical energy. Therefore, the generator will provide the electricity to the village. Next, as we can see in the picture, between the hydro intake and the hydro discharge point, there is a change in water known as the head. So when we increase the head, the water pressure will also increase. And when the water pressure is increased, it will affect the flow rate to increase. And when flow rate is increased, the efficiency will be dropped. So it is important for us to calculate the exact amount of the available head to achieve the higher efficiency. And then for maximize the energy generation, we will increase the available head, so it will increase the flow rate of the water and more energy will be produced.
Assalamualaikum warahmatullahi wabarakatuh. Today I will be presenting about the conclusion part for our report for group 1. To conclude our report, the Excel sheet that we have developed provide a comprehensive analysis for the hydroelectric system. Our Excel sheet contains 3 main calculations that can be seen, which is first to calculate the energy for question 1, and second to calculate the available head for question 2 and 4, and third to calculate the power for question 3. Question 5 doesn't include any calculation, so they just straight up theory. The data given our Excel sheet also include a graph for question 4, I believe, to plot the available head in 5 years of time. This show that the Excel can help us better to understand and also to identify trends and pattern in order to get the correct answer, or the correct answer. This graph also allowed us to analysis and also to forecast the result wanted in future in our question in 5 years of time. Overall, the Excel sheet developed for this report provide a valuable tool for analyzing the data and solving the problems provided. That's all from us. Thank you.